Hi, thanks for joining. My name's Graham Charters. I'm a senior technical staff member at IBM, and I'm the Liberty Technical Offering Manager, so responsible for WebSphere Liberty and Open Liberty. My co-speaker today is Reza Rahman. He's a principal program manager at Microsoft, and he's responsible for enterprise Java in the Azure cloud. The topic we've got today is explore Jakarta EE and MicroProfile on Azure with Open Liberty and OpenShift. So essentially what we'll be looking at is how to take existing Java EE, Jakarta EE, MicroProfile applications, running them on Liberty and running them inside containers in OpenShift in the managed Azure, the Azure managed OpenShift environment. So I'll start by presenting a few slides, talk a little bit about Java EE, Jakarta EE, MicroProfile, a little bit about Liberty and why I would recommend Liberty, other than the fact that I'm the offering manager for the technology, and also a bit about why we're collaborating. So why IBM and Microsoft are collaborating to enable these applications in the Azure cloud. Reza will then take over and do a demo. So that's the kind of meat of the session. He'll take about 20 minutes doing a demo of the technology, and then we'll talk a little bit about where we're going next, or where we'd like to go next with the collaboration. Wrap things up and then leave you with a slide with a few links on for other information. So you can take a screenshot of that if you like at the end, but also the slide should be available for download. Okay, so Jakarta EE and MicroProfile. So if you've been around Java for a few years now, you'll be aware of Java EE. Java EE started out in the late 1990s and evolved over the next kind of 15 to 20 years. And it gained great adoption, huge adoption within the industry. It was established as a set of open standards, a set of standards collaborated on by a number of vendors that gave you portability of enterprise applications across different server runtime implementations. And that proved very popular. And then more recently, Oracle donated the technology to the Eclipse Foundation and Jakarta EE was formed. So Jakarta EE is the kind of the path forward for Java EE. It's the way we're going to evolve the Java EE specifications going forward. So it gives you a way to essentially protect your investment in your existing Java EE technology. There's a path forward through the Jakarta EE standards. But also Jakarta EE is a way to build modern portable enterprise applications. And there are a number of products that implement Jakarta EE. During the development of latter stages of Java EE and prior to Jakarta EE, a group of vendors and Java user groups and users of the technology got together and formed a group called MicroProfile. And this was set up to define standards for cloud-native Java microservices. It was quickly donated to the Eclipse Foundation and has evolved a great deal since then. So Java EE, Jakarta EE, and Eclipse and MicroProfile are very complementary. MicroProfile builds on a subset of the Jakarta EE technologies to give you a kind of place to evolve your enterprise applications into the microservice world. And again, there are a number of implementations of the MicroProfile technologies. So we, in the Liberty organization, we support and have supported MicroProfile from the beginning, and we have implementations of Jakarta EE and Java EE as well. So why would you choose Liberty as a runtime for these applications? Well, we spent the past few years making Liberty an excellent runtime for cloud-based applications, cloud-native applications. So the first couple of reasons are all about trying to essentially save you costs and save you time. So Liberty is a lightweight runtime, a modular runtime, and you can pick just the components you need in support of your application. And so that helps you reduce the disk footprint and memory footprint when you're running applications, if they're potentially if they're smaller applications. Also, Liberty is a very efficient runtime, so it has high throughput. And when we combine that with the memory footprint savings that we get through the OpenJ9 JVM, then we get a very competitive runtime capability. So Liberty, for example, if we run Spring Boot applications on Liberty rather than Tomcat, you can essentially cut your cloud costs or your on-prem data center costs down to a quarter. If you compare running traditional enterprise applications on runtimes like Wildfly, I think the savings are it's down to about a third or a quarter. Also, we've optimized the runtime in terms of cloud delivery, and also as you evolve towards doing continuous integration, continuous delivery, the runtime actually fits very well with those methodologies. So we support APIs that help you integrate with Kubernetes environment. The runtime is self-tuning, so you don't have to tune it anymore for the environment you're going to deploy into, which is great if you're moving it around from one environment to another, and also if the environment changes over time. In terms of continuous delivery, we release the runtime every 4 weeks. It's a full release, and we roll in security fixes. So you means you don't build technical debt up, because you can pick the latest release and you've got the latest security fixes as part of that. We also have zero migration, which means that you don't have to migrate anymore. If you keep your application the same, and if you keep your server configuration the same, you can run on one version and then the next version and the next version, and there's no need to migrate. We don't break the APIs, we don't break the server configuration. And then lastly, developer experience. We focused a lot on trying to streamline the developer experience and also make it work very well for containerized deployments. So we have a rapid inner loop capability that lets you essentially make code, make code changes, make configuration changes, and those are automatically reflected in a running application in your server. We also have that capability supported with containers, so you can get true to production development. So why are IBM and Microsoft collaborating? Well, if you look at the cloud computing study from IDG last year, over half of the applications that are running in the cloud actually started out on-premise or on-premises. So that means that these are applications that were probably written to be deployed on-prem, not for the cloud, and have been moved to the cloud. So there's going to be a lot of Java applications doing that, a lot of Jakarta applications going that route. Also, 55% of customers use, or clients are using multiple clouds, or enterprises are using multiple clouds. So this is why it makes sense for us to demonstrate the use of OpenShift. OpenShift gives you that layer, so you can essentially have a common operational capability across different public clouds, but also on-premise. And then lastly, 54% of apps are originated on cloud. There are a lot of applications being written for cloud and still being moved to the cloud. And in fact, enterprises believe that, or 59% of enterprises believe that most or all of their applications will be running on the cloud by the end of this year. So that's the kind of intro. I'll hand it over now to Reza to do the demo. I can't hear you, Reza. I think you're on mute.
Sorry. Yeah, cool. I'm just switching over my screen now. Hopefully you can see it. Let me know. Do confirm for me if you do, please.
Yep, can see it now.
All right, excellent. So, all right, so I'm going to dive right into it. We've been working with IBM for a number of things between IBM and Microsoft. And we do have a pretty robust roadmap. We'll talk about that in a second. But basically, the first tangible thing that we've been able to produce so far is what we'll show you today. And that is basically a set of joint guidance to get OpenLiberty and Western Liberty working on Azure Red Hat OpenShift. Now, obviously, Graham has talked to you quite a bit already about OpenLiberty and Western Liberty, so we won't talk too much about that right now. I'll tell you a little bit about Azure Red Hat OpenShift. So basically, Azure Red Hat OpenShift is a fully managed OpenShift environment on Azure. It's co-developed by Microsoft and Red Hat. So basically, this is a set of instructions that it takes those technologies and puts them together and incorporates the best practices that we believe from the Microsoft and IBM side. I won't go through the entire set of instructions here, but I will give you a brief walkthrough of what we have. And this is just the beginning. There's a lot more coming to this. So there are a few things that you need to set up. Obviously, you need a Azure environment. You need an Azure environment set up with Azure Red Hat OpenShift. There's several steps here that are pretty non-trivial. A lot of it is simplified, but still you're putting together a number of different pieces. So there is some work to be done here. And basically this instructions makes it very easy instead of customers needing to figure out on their own how to do all these intricate steps. We've just basically written it down and said, hey, this is the fastest way you can get this up and running. So you need to create the OpenShift cluster. You need to set up some permissions with it. You need to set up the Azure Red Hat console, which I'll show you in just a moment. You need to connect to it, and you need to do a little bit of a setup step as what's called the kubeadmin, basically the administrative account for a given Azure Red Hat deployment. But you don't really want to be doing the real work as kubeadmin. Obviously, that poses some security risks. So there are some other things you need to do in order to enable sort of an application admin or application developer, if you will. So those steps are also outlined here. I've just to save a bit of time, I've already done all of those steps behind the scenes for us. It took me about, I think, all in all, about 45 minutes. It's not too bad, and the majority of that is actually just deploying Azure Red Hat OpenShift, because it takes a little bit to spin that up in. Initially, once you're up and running, then it's a smooth experience, as you'll see in a moment. We are using the OpenShift is a full-fledged environment on its own, right? So it does come with a number of things instead of the runtime, and it's not just a runtime per se. It's not just a simple facade over Kubernetes. For example, it does come with a built-in Docker registry, and in fact, that Docker registry is what we recommend using in this case. So you need to set that up there. I need to set up the namespace, as we mentioned. So this is a space for the little space for the application to work in, and I'll show you the namespace in just a moment. And of course, you need to set up the administrator. So I'll give you a brief tour here. I'm the administrator of this application, if you will. So I'm not running as kubeadmin. I could, right? So I could log out here and log in as kubeadmin. That's not what I really want to be doing. So if you look here, there's a number of projects that I have access to, including the actual Kubernetes cluster that OpenShift is running on. So instead of doing that, I'm just logging in as the application admin, in this case myself. So you're going to integrate actually with Azure Active Directory in order to do that. So I'll just, this is me. And here I am. Okay, so that's the setup of the so-called application admin. You do need to install the OpenShift operator. I'll show you the OpenShift, rather the OpenLiberty operator on OpenShift. I do have that set up already. You need to do that as kubeadmin. And I'll talk about the capabilities of the operator. But basically, the operator makes bridges a gap between OpenLiberty as a runtime, if you will, more specifically, OpenLiberty as a single instance, and sort of brings that concept into a Kubernetes and OpenShift cluster. So now you basically have a cluster capable, a Kubernetes cluster and an OpenShift cluster that can integrate natively with OpenLiberty, if you will. And it does a number of interesting things, like even providing you traces and dumps in a cluster-aware fashion. I'll show you about that, all that in a moment as well. But basically, the basic gist is we have the operator installed. So my cluster is now, if you will, Liberty enabled. So you need to do all of those steps, and then you get to preparing the application. I actually have an application prepared, and I'll show you. I'll basically show you the simple deployment cycle for doing that. The guidance does come with a simple application. I'll be showing you a variant of that. It's a little bit more to it than this application here. So actually, won't go through much of this verbatim. You should feel free to take a look at that. The whole point is to actually enable you to do all of these things. The only thing that I wanted to show you is sort of this graphic here that represents very well what we are actually doing. So Azure is the public cloud that you're running on. You're running Azure Red Hat OpenShift instance. So an OpenShift instance within Red Hat, within Azure. Within that, under the hood, there is a Kubernetes cluster. And then within that, you're running a Docker container. And OpenLiberty is within this Docker container. And within OpenLiberty is your Java EE application. So there's a sort of a layer cake or Russian doll effect, if you will, here. Okay, so I think that's enough of the guidance. I'll sort of keep that open just in case I need it, although I probably won't. So this is the Azure portal. So I'm logged on the portal. As I said, I've saved a little bit of time by creating a few things ahead of time. I hope I can show you some of that. Let me see if I can. The font is probably tiny. So let me see how much I can increase the font while things still being reasonably visible. Let's see. And I think that's as far as I can. So I need to minimize down a little bit. Okay, so what I have created here is the virtual network that OpenShift runs within. So this is the Azure Virtual Network. There's the cluster. There's the OpenShift cluster, as you can see. And then I have also created a simple managed Postgres instance. This is the Postgres instance that this demo application will be connecting to. So I've created those things ahead of time. As I mentioned, I've also set up the OpenShift administrator. So if you haven't seen this before, this is basically the OpenShift console vis-a-vis the Azure console. So this is me as the application administrator. So I've got access to a couple of different resources. One is the namespace where I'll be deploying the application. It's called Open Liberty Demo, very unimaginative, if you will. And then I also need access to the registry. So the built-in Docker registry that I'm going to publish out my image into, and I'll show you step by step all of that as well. So just to show you, the operator is also installed here. Wrong flow, sorry. So if I go here and go to install operators, you'll see that within my application namespace, project Open Liberty Demo, I have the Open Liberty operator installed, and we'll actually be doing the deployment and undeployment and all of those things through the Liberty operator. So it's aware of the cluster of Open Liberty instances. And as you can see, there is Open Liberty application. If I go in here, I'll be able to essentially create and manage the applications there. I'll be able to get trace and dump, which I won't show here, but it's actually reasonably easy to do that as well. So without further ado, let me show you the application. So here's the application. You can go and download, like I said, part of the instructions is the application. This is a slightly different version of it. So I have it set up in Eclipse. I'm an IDE user, I'll have to admit. I pretty much try to stay in the IDE as much as I can. It's a simple Maven project that I have. I've loaded it up in Eclipse. I also have loaded up in Eclipse an Open Liberty server instance that's running on localhost. I just want to show you that the application works locally. So here's the POM XML. I won't go through it too much. It's a very typical. In this case, I chose to use Java EE. It could be Jakarta EE, Java EE, MicroProfile, some combination thereof, whatever it is that you need that Liberty supports very well. But in this case, it's a very typical Java EE application. It's representative. It has basically all of the moving pieces. So I just have one dependency, and that's it. Right. So I'll go ahead and build my my application here. So run as Maven clean. Just want to make sure nothing gets messed up because I've been playing around with it all morning, trying to make sure the demo works smoothly. And I'm just going to do a Maven install. This will build my WAR file. Okay, so the WAR file is ready, set to go. It's sitting in my target directory, as you can see right here. Okay, so I'm going to now right-click. I'm going to close up the POM XML. There's nothing really much to see here. I won't show you too much of the application code, but it's basically Java EE code for the most part. So run as, run on server, and that's going to spin up my Liberty instance. It should be spinning up. I'm doing a cold start. A few years ago, people wouldn't imagine you could do this with a Java EE runtime, but it's very, very doable. In fact, you'll see that when I do this in Docker, it's going to be even faster. And I'll tell you why it's even faster as well. So just wait for Liberty to spin up here. Okay, should be deploying my application right about now. Okay, there it is. My application is deployed. Okay, I never liked the Eclipse built-in browser, so I'm gonna pull this up in a real browser. Okay, and there's my application. Pretty simple stuff. It's nothing sophisticated. It's just a simple CRUD application. It is using a database behind the scenes. I'll delete myself here just to demonstrate. And it is talking to that Azure Postgres instance running behind the scenes. It is running JPA CDI EJB 3.2 Lite. And it also has a JSF frontend, but in addition to the JSF frontend, there's also a REST interface. So if I go to REST, coffees here, that's the backend REST interface. You can either output XML or JSON. In this case, I just chose to show JSON, rather XML by default, because I personally find it a bit more readable. Okay, so that's it. I'm going to shut down the Liberty instance. Stop. And now let's go and do some other stuff here. So before we can do anything else to this application, we have to build it, right? So we built a WAR file. The WAR file, if I do an ls in my directory structure here, it is in the target directory. The WAR file is deployed. So I won't be able to deploy it as a WAR file though. In order to deploy it onto OpenShift, I need to build a Docker container first. So I need to Dockerize the application. So I'm going to go ahead and do that. The command to do that is here. Don't worry about if you can't read this. This is sort of my cheat sheet for the script for our demo today, if you will. So I'm gonna just run this Docker build command. So this is gonna build my Docker image. I'll show you the Docker file configuration in a moment. So I'll build the Docker image. Should build very, very quickly. There is this configure.sh script, which is very interesting. I'll talk about that in just a moment for you here. In fact, as this is going on, which won't take long, let me show you the Docker file. It's very simple. It starts with the Open Liberty kernel. Okay, so this is the minimalistic thing that you can start with Open Liberty for. And there's a number of things in the server.xml. I'll show you the server.xml while we're at it as well. So here's a server.xml that I'm using for this application. As you can see, I've explicitly specified the exact components that I need, the exact parts, in this case, parts of Java E or Jakarta E that I need. And that is actually what the configure.sh script is doing, and a bit more. I'll talk about that in a second too. So that's the server.xml. I'm copying over the database because I'm talking to the database, and then finally copying over my WAR file, and that's it. So what this configure.sh script does is that it tries to optimize whatever the deployment is, specifically looking at the server.xml file, and try to make it such that it minimizes your memory footprint and startup time when you Dockerize the application. And you'll see it, as I told you, when I run the Docker image, you'll see how much faster it actually is than running it locally through Eclipse. So hopefully by now it should definitely be done. Yeah, it is. The next step, actually, I'm going to just validate that everything is working by running the Docker image. It also serves to show you sort of that configure.sh step and what it does. So we'll just run the Docker image just locally now. That's it. So it's much faster, and it is up and running on localhost port 8080 once again. If I refresh this page, oh, and that's not good. Oh, I see. I didn't. I purposely did this to demonstrate to you that it's actually a different deployment, and then I forgot about it. So I'm just gonna exit it via the root path, and there's the same application. So this is running via the Docker container. So still everything is working just fine. So I'll just Control-C out of this. All right, so there's a Docker image. So next thing I need to do is I need to take this Docker image and I need to put it somewhere where OpenShift and Kubernetes can reach it. And what I'm going to use is actually the built-in registry. So I have the built-in registry URL all set up here. So I'm going to just go ahead and tag this newly created image. Okay, and I'm going to push it to the registry, and this should take just a moment here. So tagging the image, or rather pushing the image at this point. So I am pushing it into the built-in, remember the built-in registry that I talked about just towards the beginning of my demo. So hopefully my push will begin shortly here. And in fact, it's quite quick because I already did this in the morning. So the push is, oh dear, unauthorized Docker authentication required. So I'm going to need to authenticate myself with the, so I've timed out in the Docker registry. So I need to go up and actually make sure that I'm logged on onto the Docker registry. So here's where the instructions come in handy. And as we all know, this has to happen. Inevitably, you always have some adventures while doing live demos. All right, so that should work, and I just need to get my container registry URL, which I will do. Have that right here. All right. good. You must be logged on onto the server unauthorized. Okay. Okay. Why is that? That should have worked. Let's take a look again. Okay, maybe I need to log on into the project itself. So let me go ahead and do that. So I need to come in here, copy login command, AAD, display token, and I'm basically all I'm doing is I'm logging into OC, or rather the OpenShift command line by doing this. Hopefully that will solve the problem here. So let me log in as myself. Okay, so that should now be done. So let's retry the Docker login command now. So that's different. So hopefully I'm logged in now. Hopefully now I can push it. Okay, and here we go. Yes. Okay. All right. So this should go relatively quickly. The main thing I'm pushing here is really the configure. The output of the configure.sh file, and you'll notice it's pretty small. All in all, it's just about 46 megs for my application. So that includes my WAR file as well. So let's see if this is the push finishes. Push is done. Okay, excellent. So you do need a YAML file, a descriptor, for OpenShift to deploy the application. I'll talk you through this in a moment. So no more Docker file. So this is a YAML file, and I'll talk you through it in just a moment. So let's go ahead. So the application is now pushed into the Docker repository. We're going to go ahead and actually install the application. So we're going to go to the OpenLiberty application command here. Okay, and say create OpenLiberty application, which is basically deploy a new application. And I'm going to go to the YAML view. I could have used the UI view, but I have the YAML handy already, so I'm just going to use the YAML file that I've pre-written and paste it on here. Hopefully you can see this text. If not, I'm going to try to minimize this, maximize this a little bit more so you can see it. You know what? I'm just going to show you this in Eclipse, just to show you the syntax. Okay, so here's the syntax. This is a type of OpenLiberty application. This is referring to the operator. So we're asking the operator to do a deployment in this case. So we're giving it a name. Our application's name is very imaginative, called Java eCafe. This is a namespace. So this is a namespace I'm already working on. I have two instances of OpenLiberty running. This is what the replica equals 2 is referring to. And this is the application that I'm pulling from the Docker registry. Okay, and I'm simply saying expose equals true. This is pretty handy. So this is automatically creating an HTTP endpoint that I can access immediately just by setting up the expose equals true. Now, other than the basically making OpenLiberty natively work in a Kubernetes and OpenShift cluster, this is also very handy, right? So the equivalent of doing this in raw Kubernetes is pretty verbose. It would be at least 3 or 4 times the size of this. So this is also a nice aspect of the operators, is they make these YAML files much more compact and actually almost a DSL. Not quite. There's still some things that are a little bit verbose, but still pretty close to a DSL in terms of describing what you're actually trying to do. So I'm just going to go back into my my OpenShift console here, and I'm going to flip back to the form view so you can see the values a little bit better. So name is Java eCafe. I haven't really specified a label for this. Application image is Cafe v2, as you can see. I want 2 replicas of this. You can scale it up and down. In fact, you can do this in runtime as well. I'll show you that in a moment as well. I'm just going to go ahead and hit create. Okay. So when I hit create, you'll see the Java eCafe application here. I'm going to bump back into it and go to resources. So you'll be able to see a bunch of different information here. I could set up auto scaling. I could potentially edit edit the application deployment after it's been deployed if I wanted to. So I'll go to the resources for now. So there's 3 different types of resources that were created: the deployment itself, the service to expose the deployment to the outside world, and then an OpenShift route, right? So the route is where I'm going to go, and this is what's going to give me the URL to access this application. So here it is. This is the location. So let's see if the application is up and running already. It may or may not be. Yeah, it is. Yeah. So as you can see, very, very fast deployment cycle, right? So this is the same application with the same database, but this is a public URL, as you can see. All right. Undeploying is just as easy. So I can go back to Home, Projects, Open Liberty Demo, Installed Operators, Liberty Application. Again, I could request a dump or a trace from here as well. I'm just going to do just an undeploy, and in fact, I do that from here. Here's my Open Liberty application, and I'll just delete. Yep. Okay, so that's it. Basically, if I hit here, it should be gone. Yeah, so it doesn't exist anymore. All right, so it's as simple as that. In terms of the deployment, I think it's a pretty smooth experience all in all. Given the power and complexity of some of the underlying power and complexity of some of these technologies. So I'm going to hand it back over to Graham now to talk a bit about our roadmap. So what we just showed you, as I mentioned, is just the beginning. There's a lot more to come.
Thanks, Reza. That was a great demo, and I thought you coped with the demo gremlins admirably. I've been there myself. Okay, so in terms of where next, so Reza mentioned that we're looking to do more around the collaboration. We kind of have this view of the kind of ideal view is we have customers who use traditional WebSphere and they're deploying on-prem today in virtual machines, and they're looking to modernize those applications to Liberty, either WebSphere Liberty or Open Liberty. And what we'd like to do is kind of enable that experience. If they've chosen Azure as their cloud of choice, and then we want to enable them to get to their desired modern destination. So we're looking at things like deploying traditional WebSphere applications in Azure virtual machines, making the modernization tools available, so Transformation Advisor available in Azure to help them analyze those applications and plan deployments to WebSphere Liberty or Open Liberty. We're also looking at things like some customers who aren't doing hybrid cloud, aren't looking at OpenShift as a solution across multiple clouds, are considering or are choosing native Kubernetes services, so the Azure Kubernetes service, so looking at providing guidance and capabilities around that. And then there's the things you integrate with. So Reza mentioned database, Azure Postgres. There's on-prem database to be considered. So if you've got DB2, for example, on premises and you're wanting to integrate with that when you deploy your applications into the cloud, we're looking at things like that. But also then integration with either services within OpenShift or services within the Azure cloud. So native services like Azure Active Directory and so on. So those are the kind of areas we're looking at. We'd be interested to hear from you if any of those are of interest. Help us kind of prioritize our activities, and maybe we can let you know when things become available. So in terms of just to wrap things up, so we talked a bit about Java EE, the evolution of Java EE to Jakarta EE, and how MicroProfile helps complement those technologies for doing cloud-native microservices. We talked a little bit about Liberty as the runtime for those technologies, and how the Open Liberty operator helps you, and Reza showed how it helps you with simplifying deployment to the Azure managed OpenShift environment, makes it really, really simple. As I said, expect more from the collaboration between IBM and Microsoft, more guidance, and hopefully some additional capabilities coming soon. In terms of where you can find out more information, there's links there to the docs that Reza was showing. So we've got the Azure OpenShift documentation. We've also got links to samples. And then there are links there to a number of useful Liberty resources. So a few articles about Liberty and how it relates to other runtimes and so on. information about strategies for modernization, and then links out to OpenLiberty and guides, which are short tutorials to help you learn technologies. Reza, you've got anything to add, or we'll go on to questions?
No, just a minor point to add. So we're starting off with guidance, right? So the things that we're producing right now is how to run OpenLiberty and Webster Liberty on ARO. Shortly, we'll be releasing OpenLiberty guidance for OpenLiberty and Webster Liberty on Kubernetes. So there was a question around: is this an OpenShift operator? It is a Kubernetes operator. It is functioning in an OpenShift environment in this given setting, but the same operator is equally applicable in native Kubernetes as well. So aside from the guidance, though, we do want to improve this experience even further, right? So the guidance, as you saw, it's workable. It's not terrible, but it is nonetheless, there's some manual effort there. So there is a mechanism in Azure that's called the Azure Marketplace Solutions, and that abstracts out all of these steps. And you just click a few things on a UI, and it does even all of those things for you. So that's something we're considering doing as part of the solution, and also baking in some of those integrations. So if you want to integrate with, let's say, Azure Active Directory, you don't need to do all of that manually. You could have at least the initial setup auto-generated for you. Similar thing for VMs, right? So if you're wanting to run WebSphere ND on Azure, and you have, let's say, a 10 cluster setup, or even a 40 cluster WebSphere cluster setup, it's a lot of manual work to do all of that. Right? So similarly, you can apply Azure ARM templates and that Azure Marketplace capability to spin that up very easily. Right? Just to say, hey, I want a WebSphere cluster. Give me 10 instances and front-end it with Azure Load Balancer, point and click, and in a matter of, let's say, half hour, a couple of hours at max, you can get your VM setup all up and going, and then you can further modify that. So all of that is things we are considering. And as Graham mentioned, really at this point, what we really need is actually engagement from customers to figure out what is actually the right thing, what is required, what is helpful. Yeah, I think we can go to Q&A, Graham.
Okay. So Reza's mentioned or answered the first question we have, which was, is it an OpenShift operator? So as he said, it works in vanilla Kubernetes environment. There are a couple of capabilities as part of the operator that are specific to OpenShift. So if you use the operator in OpenShift, there are additional capabilities that integrate with OpenShift capabilities, but you can also use the same OpenLiberty operator in a Kubernetes environment. Next question was, since we have the Cloud Packs, do we have any plans to integrate Transformation Advisor to OpenShift? I'm not sure what integration that's referring to. We have, so Transformation Advisor runs in containers, so we'll run in an OpenShift environment if you want to use Transformation Advisor there. But you can also run what we call TA local. So as long as you've got a local container environment, you can run TA on your local desktop laptop.
Yep, and we're also looking into making that executable in an Azure environment as well.
Right. Yeah. Yeah. So I guess we'll hang on for a couple of minutes to see if there are any other questions that come in. Maybe a couple of minutes was a bit long. It's going to be a long, quiet pause, isn't it?
No, I think it's okay. Yeah, I think. Let's see if there's any more questions. If not, I think it's a wrap, and yeah, we'll come back. Hopefully, talk about a few more of the capabilities that we're building in the future. Yep. All right, I think we're good to go.
Yep. Thank you for joining. Thank you.